upload. So I gotta investigate. So for imagine that you have a street, and in that street you have two avenues. Let's say this is Wilshire Boulevard and Westwood, which they're not small, slowly transit spaces. How do you avoid collisions between the cars going in this way versus the cars going in this way?
I guess this one car has to be going as the other one's going the other direction.
Okay. And how do you achieve that?
You can do like a stop sign maybe or something.
Okay. Stop sign is one, yeah.
Maybe a light.
A traffic light is basically okay. What is another word for a traffic light?
Traffic stop.
Semaphore. That's like the more formal name for a traffic light.
No, I didn't know.
In computer science, there's also situations for semaphores, and that what that basically does is that if a class supports a semaphore out of the box, it's known as synchronized. It's synchronized, and if it doesn't, then it's unsynchronized. So the big difference between hash map and hash table is that hash map doesn't like traffic intersections, but it's more versatile because it allows nulls. So there's some trade-offs. It's not necessarily which one is better. Oh, it's just because it's better. It's more about like what are you trading off for one benefit and the other. So if you're not going to run anything multi-threaded, you probably are fine with a hash map. But if you're running something multi-threaded, you probably are better with a hash table. I feel like Josh has a question coming up.
No, it just came up in my research too when I was doing the homework. That same question, like, okay. But yeah, no, I'm fine.
Okay.
That's a good question.
Yeah.
About hash table. There's no way to have more than one value, right, per key.
Yes, there is.
Without using lists or something more twisted, complicated.
Yeah, you have to make like more complicated. I'm gonna start using like JSON notation. Have you guys heard about this data format?
Yeah.
Okay. Josh, have you heard about it?
I've heard of it. I don't know if I understood it when I heard it, but I've heard it.
It's very simple. It stands for JavaScript object notation. And it's basically how do we represent a complex data structure in text. And it's known as JavaScript object notation because JavaScript was the first one that implemented it this way, and it's stuck. But anything that has curly brackets is defined as a hash table. Anything that has square brackets is an array. And obviously anything that has a double quotes is a string. And if it doesn't have anything, that it's a null, or it could be a number from 0 to 9, multiple times. So if I had a situation like this, value 3, I cannot write anymore. And this is our object O. You can see the much more complicated data structure that there is. It's essentially a hash table whose keys are pointing, their keys are strings, and the values is an array. An array of strings. And you can build all sorts of nested combinations that way of those data structures. Does that make sense? Did I explain myself correctly, George?
Yeah, no, I see. I just thought there was like you know, when we initialize it and we'd say, okay, key is string, value is integer. At first I was trying to pass more than one, but doesn't work. So yeah, but I see.
To clarify
kinda-
some more of that, just to not get you all confused right now, we're gonna have a class on generics. I think the last class is generics. And generics is basically how do we make an object generic enough and still retain the properties of, like, you know, determining if the key is a string and the value is an array of strings. Like, we can actually limit it that way, but without having to rewrite the code. Okay. All right. So let's start with the second part of the session. This class, I think, is going to go fast right now because, okay. So let's, we're going to talk about exceptions. Exceptions is basically what happens when something goes wrong. And when something goes wrong, we usually have, oh, let me just fit it. You know, when something goes wrong, could be that we lost network connection. Sometimes could be that we calculated something wrong. Sometimes a file was removed from under us. Sometimes a page was removed, etc. So there's also all sorts of reasons out there why something can go wrong, right? Depending if you're a pessimist. Otherwise, you would be thinking of all the things that went right. But let's assume that something wrong happened. If we want to categorize those two things into the main two categories, is things that are related to your code and you can recover from. And then there's the things that are not related to your code that you cannot necessarily recover from because you have no control over that. And Java tries to make a difference there, or a differentiation. And it created first the class Throwable. The class Throwable is the base class for any exception. If anything, actually, let me move it there. And if anything, you know, if you guys remember, everything inherits from object, then there's a class Throwable. Don't quote me on that because there might be some more classes in between, but the root, I forgot exactly if there is, but let's actually check. No, it's directly from object. So essentially, yeah, it's object directly goes into Throwable, and then it forks into your fault, and then external. And if it is your fault, then this will use the suffix exception. And if it's somebody else's, it will use the suffix error. What's the difference between what these two classes provide, the exception and error? Nothing. It's just a naming convention. But by having that exact same set of interfaces, it just makes it the same for both of them. But the only difference is what is the class name telling you that you didn't know already. So so far so good.
Yeah.
Okay. So there are also, other than this, you know, the fact that there's exception and error. Actually, if we went here in the class Throwable, And if we went to exception, you can see all these things that, IO exception or SQL exception. Or I don't know, I'm trying to like find some other stuff that all these exceptions are things that actually happened in your application that you might want to catch. And error here is. And error deals with external things that you probably cannot recover from. For example, if one of your threads died, you're not going to be able to recover from that. You can just give a warning, and that's why you are able to catch an error, because it might not be a fatal error. It's just enough of an error that you might want to, at the very least, display to the user, hey, by the way, is the internet down? That's, that would be an error that it's outside of your control. Or you can, at the very least, have a little pop-up that tells the user, hey, is the internet down?
So these are things that are not really like related to your program at all.
The what? Sorry?
So it's like the error is like something that's not really related to your program at all.
Correct. And but it's a good practice to tell the user about it. There are two types, other than these two types that we just learned of errors. There are some two types also, if we want to slide it. And let me just move this guy to the side. There's this other set of errors that happens also. There are, runtime exceptions and regular exceptions. Who can tell me, or what does these names tell you? Regular. What do these names tell you that is the difference between these two, runtime and regular?
But is regular, by regular, do you mean like compile time? Except
no, not necessarily, but good guess. Josh, what do you think?
My first thought is, it's obvious, but I don't know if it's right, but it's something that has to be accounted for while it's running, and something that has to be accounted for on the preceding and the post period of it running.
Sort of, but okay. Yeah.
Would it be like, runtime? Is that more like if you have your program, you write your program, there's no compile errors, but if a user enters something that your program doesn't account for and it breaks it, that's like a runtime.
That's correct.
Yeah.
And regular is that, it requires the compiler was able to find it, and therefore require you to handle it. What is an example of a runtime exception? A runtime exception could be, that the file was not found. Why? Because the compiler is not going to check for every little thing and be like, oh, you're opening a file, let me see if the file exists. Like, the compiler is just going to check about general syntax. So that's one. Another one could be a division by zero. Because that could happen, as you are performing operations, and then you do a division by zero. There's no way the compiler is ever going to catch that. However, on the regular ones, it needs planning and a solid implementation. Otherwise, it won't compile. So let's try then. I'm going to try to show you this char stuff to exception stuff. let's see if this works. It compiled, but you're gonna see that arithmetic exception division by 0 was created, but it did compile. Like I could just go ahead and like, well, I can just build a project. But the arithmetic is the problem here. Again, this is a runtime error, and the other one is a regular exception. I'm going to like just jump around a little bit on this. I'll talk about handling exceptions in a second. But this is a set of common runtime exceptions. For example, array in the index out of bound exceptions. Again, if we were going to do something like this as well. How many do we have? 1, 2, 3, 4. Let's just put 4. So no, it wouldn't be 4, it would be 7, because we need something that goes over.
Yeah.
It's going to print everything except for the last item, which is, the number 7, because it's saying, by the way, you just had an array that it's this size and you're trying to access this other value that doesn't exist. Okay, so maybe let's get some numbers about this part, guys.
I'm a 9.
Oh,
Fine.
yeah, I'm fine. I'm good. Yeah, 9's fine.
Okay, perfect. So then, the big, well, so this is, essentially the same array index out of bound exceptions that we just did. Okay, so there are a few ways. During all this time, I've been talking about handling the exceptions, right? Or at the very least, in this case, you have to handle the exception. Okay, what does that mean? I'm going to handle the exception. And from those terms, handling the exception means that you either defer it for when it makes sense, or handle it right now. And that is a decision that, which one would you use? That's a decision that you have to do as a programmer, depending on your situation. So when you guys read defer, what does it make you think of?
Put it off.
Exactly. Okay, and handle right now is a way of handling it right now. Okay, so let's talk about the method of handling it right now. There is this method called try catch, and it's this block of code that doesn't matter what the exception. Actually, let's even go for our examples of that we had. Okay, we have this guy here. So this is going to cause an exception. We know it. We know it because we've run in the past and it has caused an exception. So we are going to then handle this. And the most direct way of handling it is if you are writing this, and let's just limit these to array index out of bounds exception.
Can we specify more than one catch?
Hmm?
Can we specify more than one catch? Like they are, you
Yes.
have array. Okay.
Yeah, yeah. I was heading there, but thank you for asking it in advance. Because this is essentially just going to catch one type. This essentially says, let's try this code, and if this exception happens, then this code will be executed. This E essentially is it's essentially declaring the data type. You know, we're going to catch an array index out of bound exceptions called EXC. And in this array index out of bounds exception, we were going to move this guy. We're going to see that for our array, this is great because we're catching the error without printing it. I could still output it by going X and this class is saying no. Right click, run. Oh, of course, I forgot a parentheses. Or added one more. And you see how the exception, now I'm printing the exception, and with says no. If I comment this line, the exception is gone. That's how we handle an exception right now.
Juan, how come it said 6 says no? Like, why did it say?
Oh, because it was printing the index that we had. Which is this guy.
Oh, I see. Oh, okay.
Okay, any questions? Seems a little too early still. So now we know that with try catch, when we use try catch, it's essentially handling it right now. Try and catch. That's when we handle it right now. The question then that remains open is, when do we defer it? And what does it mean to be deferred? Okay. Let's assume one thing. Let's assume that I'm going to cut all these text and create a okay, yeah, it's never used. Okay. If we were going to create an object for this exception stuff, ES equals new exception stuff, and then we can do X test or F, I don't know, ES dot X test. You can see that we're back to square one, but right now we have it all wrapped in a function, right? Okay. How do we defer it? I want to leave this function as open as possible, so that way I allow developers to use this and handle it at whatever point that they think that it's important to handle it. So, for example, here I can do throws as a keyword, and I'm going to call this array index out of bound exceptions. When I say that, I'm telling the compiler, by the way, this class, this method will throw an error. It can throw an error just be aware. It can throw an error. It's your job to pass it upstream or to resolve it yourself. And resolving it yourself, we said, or resolving it right now, that it was via what?
The try catch.
The try catch, correct. So if we did that, you're gonna see, for example, because we're kicking the can and saying this function can throw an index out of bounds exception. And that's, it is what it is. But what happens if you wanted to like defer it? Let's assume like, we're getting, if we want to handle it, I mean, we're deferring it by putting it in a function, and that function that is calling that other function. For example, if I go and create xtest2, let's see if these runtime ones are off the hook for everything. If I did exception, like it throws exception. Oh, if it just threw any generic exception, which by the way, we saw that there was a throwable class, and then we had the root of all the evils. Exception. Or errors. So this is the exception class that we are essentially throwing. Oh, I didn't have the. So we have, throwable, exception, and errors. This is the exception class that we are trying to throw in here, which is the generic, the catch-all for everything. So because I'm now actually saying it throws an exception, this function here is saying unhandled exception for Java lang exception. So in order for us to keep kicking the can, we can do throws exception. And with that, this error goes away, and now it comes down here. Where here we can either defer it but not complain whenever all of our program is just going through the tilet, or and we had what type of exception above exception? And again, I am being forced to put this try catch because we set it up over here. To say, by the way, yes, we're still deferring, we're still kicking the can. Okay?
Okay.
And now you can see, now that I handled that, that error is not even printed. It just shows it properly. Is it okay to not print errors?
I'd say no,
Why not?
because then you don't know what's going on. You don't know how to fix it, I guess.
Exactly. That's 100% the reason. Okay, there's a couple of extra topics. So let's take a break here. And then I'll see you guys in 20 minutes to continue with the rest of the exception stuff. By the way, can you guys tell me your numbers just on this?
9.5.
Yeah.
You said 9, George?
Yeah.
Okay. Josh, you were gonna say?
Yeah, mine's like an 8.75, but it's okay. It's just this last 3 minutes when you did a this.x test with a new method, but that's fine. That's fine. It's a blip on the radar.
It's a blip on the radar because we're gonna go through like all of the concepts in an exercise that we're gonna run in afterwards. So I'll see you guys here at 8:22 then. So we were at this situation where we had to decide between deferring or handling the exception right now. I think that part is somewhat clear, right? Like either we kick the can or we handle, let me put you guys up here. So or we just essentially decide to handle it right now. And that part is really easy. Again, if we decide to defer it, we have the keyword throws. And if we decide to do it right now, we use try. The main reason for deferring it would be that you want to have the flexibility to handle it at different points at some point, or to like do, you can choose at what points to actually do something about it. If you are writing the code for somebody else, then you defer it. You know, like if you're writing the interfaces for somebody else, you can let them handle it as they will. Or if you want to handle the situation at that moment, you know, I guess there's cases for everything. There is a situation here. We were also talking about an exception that it's like the root of all the exceptions. But what happens if we wanted to like handle very specific exceptions? Well, fortunately, we have a way of doing that. If we want to create our own exceptions, basically, all we have to do is to create a class that inherits from one of these other classes, like throwable or exception or errors. The easiest, fastest way would be to, like, you know, we can even let IntelliJ do it for us. In class exception. I'm just coming up with something, you know, or in session, so that it's not class. If I want to handle this as an in session exception, all I do is Alt Enter, and then I can create class in session exception, and destination package I leave it empty for the root. And now you can see that public class in session exception extends exception. And that's all I need to like be able to handle it. So, you know, let's assume that this one, we want also the exception to throw it. And let's just change it so that way, you know, it's your own way of like trying to catch rather than exception. Also here, down here, we can say we want to catch an in-session exception. Okay, that's basically how you decide that you want to create a new class. You know, you can start using it in your package by extending the exception. So, question so far. Let's get some numbers about the custom exception.
So would that new class provide the resolution to the exception, or? Okay, got it.
Yeah, because at the end of the day, try catch, what it's doing. Like, let's assume that we have even, if we try catch, where is it? Catch is going to do instance off.
Okay.
To try to catch it. So, you know, it's going to say, okay, is the object that I'm receiving instance of any of the chained catches? And then if the answer is yes, then it's going to use that one to resolve it.
One, is there, can you throw an exception in the try? Like, is there a point to doing that? Is that possible?
Yes, there is. Where you want to either switch the exception. Like, for example, if you're catching like a file not found exception, but then throw it as a new custom exception, you can do that.
Does it have to match the exception in the catch?
No. This is whatever you want to create. You know, this at the end of the day, like I've always said with programming, it's more like learning how to cook. You can mix whatever ingredients that you want. I mean, sometimes it might not taste very good, but you're gonna mix whatever ingredients according to your thing.
So Juan, would you, I guess from a style point of view, like would you throw a new exception in the try block, or would you just keep adding catch statements? Like,
depends on what you want to do. It all depends on what you actually want to do. Like, for example, like I was saying, if we are catching a network exception but reporting it as an API exception, we would do that type of switching. Like, we try it, then upon a catch, then we can actually throw it again. Anyway, seems like, let's just focus right now on the in session exception. We're gonna, I'm gonna create an example in a little bit that it's gonna clear and make you remember everything, I think.
Okay.
Okay. Like George was saying earlier, can we catch some other ones? Yes, absolutely. We can catch, and obviously, you know, in this catch body, we can do something here. And then on this one, do something else. Why is it failing here? Because we already caught the exception for the same class, so it's not gonna execute it, but we can say, I don't know, arithmetic exception, and you know, you can start chaining them, and whatever exception that is thrown, it's gonna do an instance of, and then figure out which one of these bodies catches it. Okay.
What happens if we don't specify anything? We just leave it blank.
If you just do try like this,
No, like catch, and we don't pass anything in catch.
yeah, it requires something, you know, even in between the parentheses. Like, let's assume that
Oh,
if that's what you were, it's now starting to say, okay, first of all, it's going to complain here because it's unhandled. And second, it's going to complain here because it's invalid syntax. It was saying parentheses expected. So let's see if you wanted to like leave the parentheses empty, then it's going to say the parser that there was a parameter expected. And even if I did like ES, just, you know, passing a parameter that it's now saying unknown class ES. Then if I do exception stuff, it's going to say identifier expected. Okay, let's call it A. Now it's throwing, okay, it was required a throwable because this class that I passed is not an exception, it's an object. So I'm forced to like really pass an actual exception, which, you know, this in session exception, or let's just put like just regular exception. Regular exception covers this one and this one, but if I leave like arithmetic, then this guy's not covered. The one that was throwing that problem. Now, here we're just flagging the functions to say, oh, this function throws this exception. And that's how the compiler knows about that part. But where in here are we seeing the code that is actually throwing that exception? Where do we see the code originating of this in session exception?
Wait, sorry, can you rephrase it? Where in that code do we
See where the code is, yeah, where the error that is thrown.
I guess the for loop would cause the error, but
no, but that would be a runtime exception. Right now we change it to
okay.
in session exception.
Okay. I guess the throws part, that after the throws keyword, is
That is just flagging the function to say this function throws an exception, but it's not saying, hey, here's an exception.
Would you have to define it in the in session exception class?
No, you would have to define in the function. So
I think you have to use throw.
yeah, so example 2 calls example test. I can replace all this code, you know, like just as an example. I'm going to use another keyword, throw. Notice that this one is singular, the other one is plural. Essentially, that the function is saying this function throws this exception, but the code that actually will throw that exception is this one.
Oh, got it. Okay.
If I did not include this part, then it will say that the exception is unhandled.
Okay.
Why is that? Because the compiler doesn't know the function throws an error at all?
The compiler is saying you're throwing this in session exception and you're not handling it. And remember, to handle it, we had defer or handle it right now.
Oh,
So
okay, gotcha.
if I want to defer it, then what do I do?
You have to use the throws.
Yeah, I want to tell I want to say, I want to add a flag to the function saying this function is potentially doing this. So now when I did that, it considers that exception handled.
Okay.
And it doesn't matter if then it goes up to extest, like even if we did extest2, like if we removed it, like essentially if we did this chain of events in the runtime of calling things, if we did main to ex2 to ex, and this is where it fails. Oh, I'm not sorry. So we have, let me just redo this part. If we have the main and then it goes into ex2 and then ex, and if it fails here, it will go through the entire stack. This is essentially it will go through the entire call of functions until it finds somewhere where it has been handled.
Okay, I see.
So for this reason, if we had removed these throws in session exception, now it's saying that whatever this function that it's defined here as a function that is throwing an exception is not being handled. Therefore, it needs to be handled either here or defer it again. So in this particular case, we are saying that we are deferring it again. And now it's kicking the can to here,
Okay.
where it's saying, okay, this function is supposed to handle the exception in session exception, but we're only handling arithmetic exception.
So how does it know to, well, I guess it'll tell, like if you didn't have what's called the IntelliJ to tell you like which exception, like how do you know?
No,
like
the compiler
obvious.
knows. This is
sorry,
all the compiler. This is not IntelliJ. This is the compiler. The IntelliJ is just displaying what the compiler is saying.
Okay, so the compiler will tell you what exception is necessary.
Yeah, in this particular one is saying, okay, like the error here is saying
Yeah.
on handle exception. Let me even try to run it and you'll see. Now it's saying on line 15, line 23, which is here, character 23.
Yeah.
We are finding that there is an unreported in-session exception must be caught or declared to be thrown. In other words, handle it now or defer it.
Okay.
But you can see how the compiler is helping us be consistent. So now, if I were going to just replace this arithmetic exception, now the warning goes away.
So if we handled the, I guess just to reiterate, I think we went over this, but if we did if we handled the exception in the xtest method, instead of deferring it, when we call it in xtest2, we don't need to defer it again.
We can do something as silly as this.
Okay.
You see, because we handled it, it's gone.
Yeah.
Okay, and then so in that case, can we get rid of the throws in session exception in the xtest2 method? Can we get rid of that?
And now because there's nothing that it's catching that it's saying,
Yeah.
exception is never thrown.
Okay, I see.
Now we can probably leave it as a regular exception, and that will be allowed because it knows which ones are the runtime ones, but runtime ones also are derived from exception.
Okay.
Did this make these things a little bit clearer?
Yeah. For me, yeah.
Okay, so here's an example. Let me just make sure that I'm hitting all the all the points that we're supposed to be hitting. We talked about it, handling it. We talked about a custom throwable. Some of the common functions that the throwable has. We can get the message. Essentially, the message is essentially like when we had the division by 0, that text is a message that was saying that division by 0. Print stack trace, it will tell you all the calls, like what I was saying here, that main x2 x, it will print all those until that where the error was found, all the way till the beginning of the execution. And to string, it just converts it. This is like all the exceptions have that type of method. Like I said earlier, this is just a list of the methods that do have a common runtime thing. Null pointer exception. That means that we turn something null when we were not supposed to, and we were referencing it. Here's an example. Null pointer exception. And you see the stack trace now happens here, where it's saying exception null equal, it happened on line 20. That's, exception stuff, Java line 20. That's where we found that this value is null. That's where the problem happened. So, number format exception, whenever we're trying to convert a string to an integer, that's another one. Okay, so let me then get some numbers. And we talked about chain exceptions. I'm going to talk about finally in a second. And let's get some numbers then for all the concepts that we've been reviewing with exceptions. What was yours, Josh?
No, I'll do 9.
Okay.
I'm also 9.
9. Yep. 9.
Okay, perfect. So then there's one last keyword that I want to talk about. But for that last keyword, I want to combine all the concepts into like a live, real-ish world example where we are going to get all these examples. And it's an ATM class. So when we go to the ATM, what are the two things that a bank account will require? Like, let's describe the flow of going to the ATM.
You need like a card.
Okay, when you put your card, then what happens?
Then it probably reads your account number or something.
Okay, and what is the first thing that you put your card in, and then you have to do what?
It prompts you for your PIN.
It prompts you for your PIN. So we're gonna put an int for PIN. We're oversimplifying. And then once you put your PIN number, then what happens? Let's assume you want to get money.
Probably goes through a database to make sure it matches with what it knows.
Mm-hmm. And then what else? Like in the database. And this is like a super simple. Let's say that our PIN is 1, 2, 3, 4. Very secure. And what other thing? Like if you're gonna get money, then after you put the card, you put in the PIN, it validates it, then it does what?
It asks you what you want to do.
Mm-hmm.
Okay.
Withdraw or deposit.
Okay, we want to do a withdraw.
Okay. Then it asks you how much.
Okay. And that how much has to be how much?
Less than or equal to what you got.
What was it?
Less
Like
than
less.
your balance.
More than your balance, correct. So then we are required to have a balance. And I'm making it float because it has to have like cents and stuff.
Mm-hmm.
So let's assume that we have $100 there, just for simplicity. Okay, and we're making it 100F. And we're gonna create ATM, my ATM equals new ATM. We create our new ATM object. And let's assume that we're gonna create a function called public float withdraw. And in that withdraw, we've discussed that we're gonna pass what were the two things that we wanted. What are the two inputs that we want to withdraw?
The amount.
The amount is one, yes.
Remaining.
The other one?
Um,
The first thing that you go to the ATM.
You can also specify like the denominations, right?
Well, the denomination is probably like too advanced, but I think Brandon, you were saying it.
like how much you have left? Or no, that is
No, but I mean you don't
Yeah.
input that. The bank tells you
Yeah,
how
yeah.
much you got left.
um
You have said it in the past.
did I?
Receipt, print receipt.
No.
Is your PIN? You have to
Oh,
specify your
your
PIN.
account.
Okay.
It's right. So input PIN. We're gonna call it input PIN like this. Okay. So then we're gonna validate if input PIN is the same as the PIN that we have on database or the PIN on file. Actually, let's say if they're not the same, we're gonna throw a new invalid PIN exception. And you're seeing that it's in red because I'm inventing it right now. So I'm gonna create that class for the invalid PIN exception. And I'm gonna put it in the main package. Okay. That PIN, now it's comparing that it's unhandled, that it's complaining that it's unhandled. So I'm gonna Alt Enter again. And I'm gonna say add exception to method signature because I'm gonna defer it. I could choose surround with try catch to handle it right now or defer it. So I'm gonna defer it. Okay, so assuming that then once we get to this point, then we assume that the PIN is correct. Then George, you said there was another operation that it does.
The
With the
denomination.
amount. No, with the amount.
Oh, it checks, you know, if you can actually get it back, if it's less than your balance.
Okay, so if amount is greater than balance, then we're gonna throw new insufficient funds exception. And I'm gonna again, Alt Enter, create class, same thing, destination package. We come back here because he created it. Now it's complaining you're not handling that exception. First error was I don't know about that exception. Then the second is, well, I know about it now, but you are not handling it. What do we do?
Add it to the method signature.
We added the exception to method signature. And now you can see that they were separated by commas. Like I can be saying that this method will throw these two methods, right?
Yeah.
Okay.
So in a way,
No, sorry. What were you gonna say, Josh?
so as an analogy, in a way, it's kind of aggregating the exceptions much in the same way as a class that needs individual methods from different packages aggregates them at the top.
Yeah. We're essentially defining things. So that way the compiler doesn't have to look at the full logic all the time to know what the method is doing. Okay. So now that we have that amount equals balance, then assuming that we get to this point, that then we do this dot balance minus equals amount. And we return amount. We confirm now that we were able to return you the amount that you wanted. You know, you pick up the money from the ATM virtually. So far, so good. Okay. Like I said, this is very simple, but very powerful to like understand everything there is about exceptions. We've so far touched throws. We've so far touched throw. and, essentially like creating the amount. So my ATM, what do we call here? What is the function that we got to call?
Withdraw.
Draw.
Yeah, withdraw.
Withdraw.
Yes. Okay, withdraw. Yeah.
Is for the withdraw function, shouldn't it return the balance, or should it return?
No, because when you go to the ATM, what do you pull out of the ATM? You say, I want $200. And what do you pull out? $200. Sure, that might give you the receipt, and we could actually tweak it to like you get the receipt and the amount, but technically you're getting the money, and we're subtracting the account.
Okay.
The amount that you wanted.
Okay, so we're going to now pass the amount. So we're gonna what were the arguments that we were gonna pass into the amount and into the pin? I mean, into the withdraw function.
Money we want in our pen.
Okay, what amount are we gonna put in here?
50.
What is it?
50.
50. Okay, 50, and then what pin are we gonna put?
1, 2, 3, 4.
1, 2, 3, 4. Okay, so we're assuming that we're doing it right.
Yeah.
Okay, but this guy is now telling us something, right? What is this telling us?
Saying there's an unhandled exception.
Yeah. In this particular case, I vote for handling it right now. And now that I surrounded these with a try catch, it essentially chained both of the exceptions here.
Oh.
And now we have, even printing the stack trace of those exceptions. But I don't want this the stack trace. The reason why I created this insufficient funds exception is so that I can catch him and display a proper message. So here I'm going to delete this, and I'm going to say, sorry, your pin is incorrect. Which is basically what we're doing with exception. This is why we wanted that, to be able to display. If I display the stack trace to the user, it would be like, what is this? I don't even know. But if the user sees, sorry, your pin is incorrect, it means something, right?
Yeah.
Okay, so if we do insufficient funds exception, we can now. What's my non-lazy? I know. Sorry, you have insufficient balance. Okay, so now we have it technically handled. Oh, and it finished without a problem. So what I'm gonna do is that I'm gonna catch the value float withdrawn. One second. Float withdrawn, and then I'm going to print the withdrawn. Essentially saying you withdrew that amount. Did I write it correctly? Yes. Okay. So now if I run it, because it's correct, it's gonna saying you withdrew 50, and now also we can even print the balance by saying your balance is, and then we do ATM, my ATM dot balance. So now you can see the proper messages, right?
Mm-hmm.
Now what happens when we do change the pin? Sorry, your pin is incorrect. Or when I put 200 and we only had 100 in. Sorry, you have insufficient balance.
It'll print both if you didn't change it back, right?
Well, if I change it to this, it will only print one, because That's the way that an ATM does. If I put the incorrect pin, it's not going to check the balance, right?
Oh,
And that's the correct behavior, because you don't want to reveal, you don't want somebody that has your card to be able to get the balance.
Right. Yeah.
You know,
That gives information.
Yeah.
So here's another thing. What happens when in the ATM when I put an incorrect pin?
Catch block will.
Yeah, it tells you that it's the incorrect pin. But then what does the ATM start doing?
It'll ask you again for your pin.
Yeah, and let's assume that I did it 2 or 3 times, whatever the limit is. There's something else that the ATM does afterwards.
A
They
hard
lock you out.
goodbye.
What is it?
A hard goodbye.
Well, no, there's one thing that it starts doing. Regardless of the transaction that you did, successful or unsuccessful, at the very end. At the very end, it will start beeping and saying, pick up your card. Doesn't matter if it was an incorrect pin. Doesn't matter if it was a correct pin. Doesn't matter if you got the money or not. The ATM will start beeping and telling you, pick up that card. Right? Okay. How do we achieve that? Where there's one extra keyword that exists that it's called finally. And finally will execute no matter what happened above.
So it's not really like an error, it's just kind of like a message.
It's just a
Just the line.
cleaning up mechanism for executing at the very end of the try catch block. So now we can add something here that would say, pick up your card. And doesn't matter if we are, running it with an incorrect pin, it's going to say, sorry, your pin is incorrect, pick up your card. Or if we put the correct values and run the ATM.main. Oh, here's 1, 2, 3, 4. Oh, we don't have insufficient balance, pick up your card. Or even if we say, okay, we go back to checking out $20. We run it away. We run it again and it said you withdrew 20, your balance is 80, pick up your card. You see how doesn't matter what happened in that try catch block, this executed.
Yeah.
Now, this might seem like insignificant because, oh, wow, what, I could have technically just done this, essentially commented out, and I would have the same thing, right?
Mm-hmm.
But this is a big difference. This is a very, 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 very big difference. Where do we have the other exception stuff? If we did like even int a equals 10, int b equals 0, and then we did, oh, my keyboard is dropping. 1 second. I know you're probably hungry, and I just give me a few minutes. Like more like I'll give you all the cookies that you want. A divided by B. I know. So let's assume that we have this A divided by B, right? And that's going to crash. That's going to say arithmetic exception division by 0. Even if I were to print here after that exception, right? After that exception, that does not execute that here line. So if I were to then do, again, try, and then put it here, catch, 1 second, Daisy. Even if I wanted to do something like this, and if I want to catch it, I'm going to force the program to exit. You can see that I am forcing the program and I never got to this line. What happens if I do this? Oh, here I actually exited. What happens? Well, in this particular case, it's actually exiting, but the finally is important in the sense that it's a guaranteed execution. Obviously, here I am just like forcing the exit of the function. I mean of the program by killing the program. But if I do a return, you can see that this even executed. Even the spy, like, I'm gonna remove the finally. Finally did not, like, if I remove the finally, the return, this here doesn't happen. On the system.exit, it's because it's killing the process immediately. But here, it's forcing that execution. Does that make sense?
Yeah. Juan, for like not okay, for exceptions that we don't write, or like like ones that are not custom, like the built-in ones, is it basically like throwing an error and then just is there like a break statement in there when they write that, so that it just doesn't, you're not allowed to call any more functions?
No, it's a well, so when are you talking about, like, if I was going to have like all these chained exceptions?
Well, like when you did I guess that doesn't make sense. I was just wondering, because if you throw, like you showed an example before, if you throw an exception and then the error message pops up, like nothing pops up after that. So is that breaking the program? Like, is it?
Oh, no. In for example, in the ATM, once we like, oh, you mean here? Yeah, it exits a function. Like, if it gets to this point, to this line, and executes it, it exits the function. This part won't be executed because it left the function right here.
Okay. So I guess like in the invalid pin exception, when we're writing our own custom exception, do we need to require it to break, or like what?
Okay.
It's empty.
So how does it know to break?
That's just the runtime. The runtime is doing that. Like the runtime with throw, it blocks the execution of the rest of the function because it's pointless at that point to continue executing something that it's going to be in an unknown state.
Okay, I see. So it's probably like something in the throwable class that's telling it to.
Well, no, it's in the runtime, in the compiler runtime.
Oh, it's in the okay.
It's not gonna. The entire point of all this is to make things more predictable and more stable. So there's no point in continuing the execution of something that it's going to be unpredictable.
It's like user accessibility stuff.
It's like what?
Like user accessibility stuff.
Yeah, it basically does. Like C++ and all those old languages didn't have these type of exception handling. And Java was it was C++ the one that first started introducing it, but Java kind of perfected it. Okay, so we've covered finally, we've covered all the keywords, we've covered throwing exceptions, a custom throwable. There's one data structure that, I don't know if it adds more, but to the conversation more than just teaching you another data structure, but let's cover it because I want you guys to like walk away with knowing what is a stack, what is a queue, all these different data structures. But it's more like we're going to cover it at a high level rather than going directly into the code. And then the homework is that we want to do a password check function. This is like pseudocode where we prompt twice for the password, like the typical thing where you are prompted twice for the password to validate it. So if the passwords are different, then it throws an exception for this. And if it does it 3 times, then it's like, okay, you know, there's no point in doing this forever. So that's kind of like the exercise. As you have noticed, probably all these homework exercises are utilizing things that you have used or seen or at some point, you know, dealt with, you know, parking garages, splitting a check, you know, if you've lived any of those things, it's pretty normal and pretty common. Same thing with, like, you know, doing your password verification.
Yeah, like the last homework, I mean, to check to make sure I was right, you know, I just did Control F on it for all those words.
Yeah.
Yeah.
Yeah, and Control F is something that everybody does all the time, you know. Okay, so then as a last topic then of the session, I would like to discuss what is a stack. And don't cry, because I gotta bring these books. Okay, this is a stack of books, right? If we had them on the table, would I grab the bottom one? Would it be easy to grab the bottom one if you have a stack? The easiest thing is to either put on top, come on, put on top, or remove from the top. In other words, the last item in is the first one out. And I'm going to repeat that so that you guys have a second to think about it. The last item in a stack, which is the last one that you put on top, is the first one that goes out. That's the quality of a stack. That's why it's known as a LIFO. Last in, first out. And it has 2 main methods. Push, which puts it on the top, and pop, which removes it from the top. And maybe you might have a peek to see what is the item at the top. And that's it. So in a stack, if we were going to think of situations or places where a stack is utilized as a data structure, let me show you one. I know, Daisy. This is a stack. Actually, hang on. Your opinion is incorrect. E.print stack trace. It even has a word stack, because it's essentially putting like all the steps of, you know, we called it from main, and then we called it from withdraw, and that's where the exception happened. And if we had more methods, the stack would continue to grow up. And as it is exploring where things were called, the stack is being emptied by saying, okay, I'm printing that it came from withdraw, okay, and then withdraw was called from line 22. So you can see all the way until the beginning where it started executing. Any questions about this? Okay. Okay, so then let's go through numbers. Let's get some numbers then, guys.
Sorry, yeah, I'm good. Mine's fine.
Okay. George?
Yeah, 9.
Brandon?
Yeah.
Okay, perfect. So then basically that's the session for today. I thought that we went through it fast, or faster than other times. But if then there's no questions or anything, then I'll stop the recording, because that's, you know, the session of today.